Okay, so this is going to be just a brief review of predicting products of chemical reactions. So when you predict products, it's really important to do a couple of things. The first thing is, before you try to write the products, look at the reactants and think about what type of reaction this is. Okay, that's the first thing. The second thing is that whenever you're writing a product that's an ionic compound, you need to think about what the charges are and make sure you write the formula correctly. You can't just carry subscripts over from the reactant side to the product side, and I'll show you what I mean by that in a second. Okay, so let's take these one by one. Now remember, we have 5 major types of reactions, and of course there's subtypes, and it's a little more complicated than that, but for now let's just assume we have 5 types of reactions. Synthesis, where 2 products come together to form one. Decomposition, where synthesis where 2 reactants come together to form one product. Decomposition, where 1 reactant forms 2 or more products. Single replacement, where an element in a compound react and the element takes the place of one of the elements in the compound. Combustion, where a hydrocarbon reacts with oxygen to produce CO2 and water. And double replacement, where 2 ionic compounds basically switch cation and anion pairs. So looking at the first one, we just have 1 reactant. So there's really only one thing that this could do, which is decompose. So we know we have decomposition. Okay, so this has to break into its elements. Now, you might be tempted to write Cu2 plus O, but that's not correct. When we write an element, it only gets a subscript if it's one of our 7 diatomic molecules. And you might remember those with Brinkelhoff: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, or my personal favorite, Hun and the halogens, which will totally be my band name when I form an awesome science teacher band. Okay, so copper is not part of those, so it is just Cu, okay? And then oxygen, however, is one of the diatomics, so I would write O2. Now, this might visually bother you because it's totally not balanced, but we can easily fix that with coefficients, right? So there's 2 oxygens here and only 1 here, so I need a 2 and then a 4 to balance copper. Okay, so don't balance with subscripts, write the products correctly, and then use coefficients to balance the equation. Okay, so here we have silver reacting with chlorine. Now, silver is located in the D block, which might make you think that it has multiple oxidation states. But silver is one of the exceptions, so it's always going to be +1. Okay, I'm not holding you responsible for that just yet, but we'll focus on that as an exception in Unit 2. Now, chlorine, looking at the periodic table, is going to have a charge of -1. Okay, so we have one of each of these that will make a neutral compound. So you can't just write AgCl2, you have to write AgCl. Now, is it balanced? No, but that's fine. We put a 2 here and a 2 here. Something that people get a little confused about sometimes with the diatomic molecules is they just always want to put a 2 on those elements whenever they see them. That's only when they're on their own and not in a compound. When they're in a compound, you always have to consider the charges to write it correctly. Okay, now, we have 2 single replacements here, and you can tell that they're single replacements because they have an element and then a compound. Okay, so in this single replacement, sodium is a metal, so it's going to replace the other metal. Now, sometimes single replacements have no reaction, and in order to figure that out, you have to use an activity series. So I'm going to give you guys the comparisons with each of these. So sodium is more reactive than magnesium. And copper is less reactive than potassium. Now, the rule here that you might have forgotten, and that's fine, is that the more reactive element tends to be in the compound. And that's because sodium is going to be more stable when it has a +1 charge. So in this case, this reaction will occur. Sodium will replace magnesium, so magnesium will go on its own. Now, you might just be tempted to write NaO, but that would not be correct because we have to think about the charges. Okay, so we know that sodium will have a +1 charge and oxygen will be -2. And that's based on the number of electrons I need to gain or lose to have a stable noble gas configuration. So my formula would then be Na2O, because I need 2 sodiums to balance out 1 oxide ion. Okay, so then to balance this, all I have to do is put a 2 here. Now, in the next example, since copper is less reactive than potassium, the more reactive metal is already in the compound. So what that means is that this will be no reaction. Nothing's going to happen. Okay? Now the next one is a combustion reaction. We know that because we have a hydrocarbon and oxygen. I will tell you, people often get these confused for single replacement because they see, oh, well, it's a compound and an element. But be careful, okay? Anytime you see that, make sure you're paying attention to what that compound is. So these always form carbon dioxide and water. A trick you might have forgotten from Chem 1 as far as balancing is balance in the order carbon, hydrogen, oxygen. So first I balance carbon with a 4 here. Then I balance hydrogen with a 4 here. I count my total number of oxygens, which is 8 plus 4, so 12, and I put a 6 here. Should you find yourself with an odd number of oxygens here at the end, put a 2 in front of the original hydrocarbon, double each of those, and that will fix your problem. Okay? Now the last one is an example of a double replacement. I have 2 ionic compounds here. So basically, the cation in the first element is going to go with the anion in the second, and the cation in the second is going to go with the anion of the first. When you do these, it's so important to think about the charges before you recombine. We know nitrate has a -1 charge, so even if you didn't know that silver is always +1, you could figure it out from the nitrate. We know that barium is +2 and chlorine is -1. Okay, so when silver combines with chlorine, it's just going to be AgCl. And when barium combines with nitrate, I'm going to need 2 nitrates for 1 barium. Now, a couple things here. First, even though we see the anion before the cation, when we write the formula, we always still have to write the cation first. So we'd write barium. Whenever we need to have more than one of a polyatomic ion, remember that we put it in parentheses. Okay? So then to balance this equation, I would put a 2 here and a 2 here. Okay? Again, I'll link the longer IB Chem 1 lesson that has like a lot more examples, but this is just a quick review for those who need that.